Hello everyone. So as we have discussed in the previous videos about what is moment distribution table, rotation factor, carryover moment and carryover factor. So let us take a simple example and let's try to solve this continuous beam using the moment distribution method. Okay. All right. So in this given problem, it is as analyze the continuous beam as shown in the figure by moment distribution method and draw bending moment and shear force diagram. Okay. And also draw the elastic curve of the beam. Okay. Now you can see here it is same again a continuous beam only with uh, indeterminacy is greater than 3. You can see here it's a fixed support. Okay. Fixed. So 3 reactions here roller fourth reaction, and again there is a fixed support here 5 6 7 reactions. So 7 reactions, but you have equations of equilibrium only 3. Okay, so this is a indeterminate structure. Okay, so again indeterminate structures can be solved by using, so for earlier method we have in the first module we have solved it using the slope deflection method, and now we are going to solve it at moment distribution method. Okay, so AB is of span 6 meter and BC is of span 6 meter. In AB, there is a UDL of 30 kilonewton meter, and in BC, there is a point load of 72 kilonewton. And AB has 3I and BC has 2I. Okay. All right. So as usual, the steps would be more or less the same, but the method applied here would be different. Okay. Now see here. The first step is fixed end moments. So earlier also we have found the same thing, finding fixed end moments. Same formula would be used. There in the second step would be developing the slope deflection equation. But here what we'll be using is the second is distribution factor, then moment distribution, followed by, once you get the moment distribution, draw the bending moment and shear force diagram. The important thing is these two steps here, distribution factor and moment distribution table. Okay, to formulate this is important. Okay, now the first thing is first finding fixed end moments. So fixed end moments is same, uh, that is AB. So there is a UDL here. So MFAB is again star A is the first point. So minus WL square by 12. B, and that is minus 90 kilonewton meter, and MFB is plus 90 plus WL square by 12. Next MFBC is again it's eccentric load, so W AB square by L square, and first is this is minus WAB square by L square, and MFCB is plus plus WA square B by L square. Okay, all right. Next thing is finding the distribution factor. Now how to find this distribution factor is, now see here, first joint here is B. So B is the joint which connects AB also, that is BA from the side, and BC. So you have to take a joint in such a way that it connects two members. Okay, so this is one joint now. So joint B, I'll write it here. So, and again the table should be as such: joint member K summation K distribution factor. Okay, first joint. So B is the only joint which connects the two members here, that is BA and BC. Again, the sequence of this writing should be also same, because BA is not as same as AB. Okay, so writing this is very important. So this is BA and this is BC. Okay, so BA. Now distribution factor is nothing but if I apply a moment here. Okay, if I apply a moment here, half of the moment gets carry over here. Okay, because the moment is applied here, it gets distributed here on B, that is on A also, because A is a fixed support, and on C also, because C also is a fixed support. Okay, so if the far end, now this is point B, it is connecting A, and A is a fixed support. If this is the case, then the formula used here, that is K is nothing but the stiffness. Stiffness of the beam is given by 4EI by L. Once again, if with respect to the given support, that is B, with respect to the given joint, if the far end, which we are going to find here, BA, A is the far end, again here C is the far end with respect to B. The far end, if the far end supports are fixed supports, then K would be 4EI by L. So that's why I'm going to write it here. K is nothing but the stiffness of the matrix, means how stiff it is against the loading, stiffness. Okay, So 4e, I here in this BA span is 3i. So I'll write it as I, in case of I, I'll write it as 3i divided by L. L is 6. So it is 2ei. Similarly, with respect to B, C is also fixed support. Now fixed support, so far end is fixed. So the far end here is fixed support. So here also it would be same. So it is 4e instead of I. Now BC span has 2i. So it is 2i by L. So again solve this. Then summation k. Now summation k is nothing but it is sum of, that is add these both. Okay, only at the joint which members connect, add these both. Okay, that is 2ei plus 1.33 ei. So it is 3.33. So summation k is total of this joint. So in this joint, so summation k is 3.33 ei. So the distribution factor is now, it is given by k by summation k. So k is 2 by 3.33. Okay, so 2 by 3.33 is 0.6. Again, 1.33 divided by 3.33 is zero point 0.4. The check is when you add both of these, when for a given joint, when you add the distribution factor, it should the sum should be 1. So it is 0.6 plus zero point 0.4, that is 1. Okay, all right. So once you find this distribution factor, next is this is most important, moment distribution table. Finding the moments. Okay, there you used to find the moments with the help of this slope deflection equation, and then we used to find the joint equilibrium equation. So here we are going to use moment distribution table. Again, the table should be like this only. First should be joint. Obviously, the joint are connecting the members. In the next line, you should write members. Third should be the distribution factor, and finally, the fourth should be fixed end moments. So first is joint AB. Now, the most important thing is you should draw this table in such a way that it looks like the beam only. Now, see here, A, B, C. So it should be like this only, joint A, B, C. At B, there are two members connecting. So you can write here, actually you can write this here member. So this is AB, BA, BC, and here you can write CB. Okay. Then distribution factor. For we have found only distribution factor can be found only at the joint where it connects two members. So that's why at A it is AB, it is dash. You can just write it dash or 0. Only it will exist at the joint B. So B A, we have already found it. BA is 0.6, then BC is 0.4. Okay, so 0.6, 0.4. Again, you should draw this line here only as such. Exactly at B, because it connects BA also, BC also. Okay, next is writing the fixed end moments. We have already calculated this fixed end moments here. So first is minus 90, plus 90, minus 32, plus 64. So write it accordingly below here. Minus 90, plus 90, minus 32, plus 64. Okay. Now, the most important thing here is how to calculate the next moments here. Okay. So what you're supposed to do is, okay, so we are going to distribute this. We are only calculating at this joint first, because wherever we have calculated the distribution factor, at that joint, we should calculate the moments. We have to do alterations at that moments. Okay. So now you can see here 90. Okay, add both of these, whatever is the signs here. So it is 90 minus 32. Okay, so this is 90. Okay, only at this joint. At B you have to do all the alterations, because at these two joints we are going to because BA and BC are connected together at B. So only at these two joints there is distribution factor which exists, and alterations should be done. The moment should be modified at this joint. Okay, now you can see here this is 90 plus 90 minus 32. So try this in the calci, plus 90 minus 32 in the calci. So it is plus 58. Now this plus 58, what you have to do, answer is negative, positive. So you have to change the sign now. So whatever is the answer here. So if it is positive, then you have to write it here negative. If it is negative, then only takes the sign here as negative. Okay, so now the answer is plus 58. Now plus means just write this as minus minus. Okay, minus minus, then 58, whatever the answer you've got here, 90 minus 32 is 58. So that 58 into this point 0.6. So 58 into point 0.6 would give you 58 into point 0.6 would give you 34.8. Okay, so what you're supposed to do is whenever you try to solve this, so here you've got answer positive, so it is plus 58 every time. If it is minus 58, you have to change the signs to plus. Now if it is plus 58, you have to change the sign, only change the sign here. So as of now it is plus 58, so change the sign to minus and minus, just write this and keep it off. Then whatever is the numericals here, multiply that. So it is 58 into zero point 0.6, so it is 34.8. Next, same, 58 into zero point 0.4 is 23.2. Okay, so multiply this with the distribution factor. Okay, once you solve this, so again this would be repetitive. So after writing this fixed end moments, okay, then this is the alterations done. Then it would be carryover moment. So whatever moment you have got here, that gets carried away. So in BA, whatever is there in BA, it gets carried over at A. How much it get carry over? Half of it. Similarly, whatever moment is created at in BC, half of it gets carried away at CB. This portion. Now, why it gets carried away only at this portion, that is A and C, is because A, as I've told you, moment which is created at B gets half of the moment, which it gets distributed here. That is, half moment gets distributed at A. Again, why A? Because A is a fixed support. A fixed support has the moments. So same thing here also. At B, in BC span, whatever is there in BC span, half of the moment gets carried away. That is at C. Again, why C? Because C is a simply it's a fixed support. Okay, so the same thing here. Now this minus 34.8, half of this is again, half of this 34.8 is 17.4. Again, with the minus sign, it gets carried away. So that's called as a carryover moment. So carryover moment exists when the nearest support is a fixed support. There it gets carried over. It gets a carryover moment. Similarly, in this point also, minus 23.2, half of this is minus 11.6. It gets half. So we have to just 23.2 divided by 2. If you do, we'll get this moment. Okay. Now this is the time you need to stop. Again, why you need to stop is here. Final moments you already carried over here. Okay, so last is this carryover moments. So you cannot do any further iterations. So you need to stop it here. Okay, once you stop this here, next is final moments. So this is a simple problem where you don't have to do too many iterations. But as you go on in the further problems, you need to do a lot of carryover moments and fixed end moments again here. Hmm? Okay, so once you drawing this arrow is also important, okay, because immediately it gets carried over in the next step only. Here also it immediately gets carried over in next step. Okay, now is you have to so ultimately add this column. Now you can see here minus 90 minus 17.4 minus 107.4. Okay, then 90 minus 34.8. Straight away, whatever is the sign. So it is plus 90 minus 34, only this column. Plus 90 minus 34.8 is plus 55.2. Next, minus 32 minus 23.2 is minus 55.2. And then finally this column plus 64 minus 11.6 is 52.4. Okay, now the check here is whatever you've done is right or wrong. You'll get to know when you come across this joint. So at B, joint B, the moment should be equal and opposite. So here it is plus 55.2, here it is minus 55.2. Okay, so whatever you've done is right. The same moments you have to show it in the beam. Okay, the same moments you have to show it in the beam. Okay, now you can see here If you want to draw the bending moment diagram, first show the beam like this, A, B, C. Then again, as usual, same thing. First, free bending moment for span AB. So AB is a UDL, so it is WL square by 8. So it is 135. So it is a parabolic curve. Next, mm, and BC, it is WAB by L, so it is 96. So first draw this. Then see here at A it is negative. So minus means anti-clockwise. So anti-clockwise is 107.4. Mark it here. Next, in BA span. So BA span is clockwise. So clockwise means show it like this, clockwise, 55. Again, you have to show it in the left side of B because it is connecting BA. Similarly, in right side of BC, so here it is minus. Minus means again here anti-clockwise.